Have you ever faced a situation where your database queries just aren't performing as expected? It's frustrating, right? If that's you, then you're in the right place. Today, we're diving into a common issue with Postgres 9.6 and Parallel XPath queries. I understand how annoying it can be when you expect your database to handle queries efficiently, only to find that some are running sequentially instead of in parallel. You're definitely not alone in this struggle. Many users have encountered similar issues. Here's the specific situation we're looking at. One user recently asked, "Why is my XPath query on an XML column always running sequentially in Postgres 9.6? They mentioned that both XPath functions are marked as parallel safe, yet they still experience sequential execution. Sound familiar? Let's explore this together. So what could be causing this issue? Even though the functions are marked as parallel safe, there are several factors that can affect parallel execution, such as the query structure, data size, and system configuration. We'll break it down step by step to help you understand what's going on. And don't go anywhere. I've got a crucial tip at the end that could help you optimize your queries for better performance. To address the issue of sequential execution in the XPath query, the user should first check the configuration settings for parallel query execution in PostgreSQL. This includes ensuring that the parallel worker settings are appropriately configured. Next, the user should analyze the query plan to understand why the query is not executing in parallel. This can be done by using the explain command to see the execution plan details. The user should also consider the size of the data being processed. If the XML data is too small, PostgreSQL may decide that parallel execution is not beneficial. In such cases, increasing the size of the data or modifying the query could help. Additionally, the user can experiment with the cost settings for the XPath function. Adjusting the cost parameters can influence the planner's decision to use parallel execution. Finally, the user should ensure that the PostgreSQL version is up to date. While the user is on version 9.6, later versions may have improved parallel query capabilities. Did you know? The concept of parallel processing dates back to the 1960s. It's amazing how far we've come in optimizing database performance. Now, let's look at the answers provided by other users. This user points out an important distinction between relation size and total relation size in PostgreSQL. They explain that large XML column values are stored in a toast table, which means they don't count towards the relation size that the optimizer uses to evaluate parallel plans. To enable parallel execution, the user suggests adjusting the minimum parallel relation size. They demonstrate how setting this value to 136 kilobytes allows for a parallel sequential scan instead of a sequential scan. Here's the crucial tip I promised. Regularly review and optimize your database configurations and queries. This habit can significantly improve your query performance over time. And there you have it. With these steps, you should be able to troubleshoot and optimize your XPath queries in Postgres 9.6. Remember, regular maintenance and review are key. If you found this helpful, hit the subscribe button for more tips, and don't miss our next video on advanced query optimization.